Hello everyone, welcome to this session on cloud HPC offerings, and again welcome to my channel Prevention is Better Than Cure. This is Dr. Chiranjeevi Manike. In this video, we will explore how cloud platforms like AWS, Amazon Web Services, Microsoft Azure, and GCP, Google Cloud Service Provider, provides a high performance computing solutions. So we'll also understand virtual clusters and different cost models used in cloud computing. Let us see one by one. Like so, let us begin with the cloud HPC offerings and their importance in the modern computing. The high performance computing or HPC. This is used to solve the complex computational problems. So traditionally, HPC required expensive supercomputers, but now the cloud platforms make it accessible to everyone. Why? What is HPC? So I already explained about this. HPC involves the parallel processing using the multiple CPUs or GPUs to perform the large scale computations efficiently. So why the a cloud for HPC? And this cloud computing eliminates the need for the upfront hardware investments. It provides a scalability, flexibility, and also and global access to the computing resources. So first, let us understand why the cloud for the HPC. The cloud computing has transformed the high performance computing by removing the need for expensive upfront hardware investments. So, because traditionally organizations had to purchase and maintain the supercomputers, so which required a significantly or a significant capital and also space, also ongoing maintenance cost. So with the cloud platforms like Microsoft Azure, mm, Amazon Web Services, and Google Cloud Service providers, users cloud platforms users can access the powerful computing resources on demand without owning any physical infrastructure. So one of the biggest advantages is scalability. So you can start with a small number of compute nodes and scale up to the thousands of cores within the minutes, depending on your workload requirement. So cloud also provides flexibility. That is, users can choose the different configurations such as CPU, GPU, memory, and storage based on the type of applications, whether it is a scientific simulation, machine learning, or big data analytics. Another key benefit is a global accessibility. Like a cloud data centers are distributed worldwide, so that allows users to run the workloads from anywhere and also collaborate easily across the regions. So additionally, cloud platform offer advanced features like automated deployment, monitoring, and fault tolerance. So that makes the HPC more efficient and easier to manage. Overall, cloud computing makes the HPC more accessible, cost effective, and scalable for both the researchers and enterprises. Major cloud service providers, if you look at the major cloud service providers are AWS, Amazon Web Services, Microsoft Azure, and GCP. This Microsoft Amazon Web Services offer powerful HPC solutions like EC2 instances, parallel cluster, and batch. It supports the GPU and high memory computing, highly scalable with the pay-as-you-go pricing. This is widely used for simulations, AI, and big data workloads. And another next that is cloud service provider is Microsoft Azure. And this Azure provides HPC through the Azure virtual machines and Azure Batch. So strong integration with enterprise tools and Windows ecosystem, which offers the specialized hardware like InfiniBand for the low latency. This is suitable for engineers, research, and enterprise applications. Next, Google Cloud Platform, GCP. It offers the HPC via Compute Engine and Kubernetes. This is strong in data analytics and machine learning integration. It provides a high performance networking and GPUs or TPUs. This is ideal for AI driven and data intensive workloads. So these cloud service providers enable organizations to access powerful HPC resources on the demand. So we can eliminate the need for expensive on-premises infrastructure while offering the scalability, flexibility, and cost efficiency. And if you look at uh, the AWS HPC like EC2 and Elastic Fabric adapter, like mainly in this HPC offers the auto scaling clusters, GPU based computing, and also the flexible storage options for the HPC workloads. And this automatically adds or removes the compute nodes based on the workload demand and also ensures optimal resource utilization and cost efficiency. So this is ideal for workloads with a varying computational needs. And the GPU based computing, that is, it provides powerful GPU instances like NVIDIA GPUs for accelerating computing. This is mainly suitable for the machine learning, simulations, and the deep learning, so which enables the faster processing of complex computations. Next, it has the flexible storage options. It offers like multiple storage services such as S3 bucket, EBS, elastic block storage, and FSX. It supports both the high performance and scalable storage needs, so that ensure the efficient handling of large data sets in HPC applications. So AWS provides a robust HPC ecosystem with a scalability, high performance, and flexible storage that makes it preferred choice for the data intensive and compute heavy workloads. So Azure provides HPC through the virtual machines, Azure Cycle Cloud for a cluster management, and InfiniBand networking for high performance. So if you just look at in detail of this Microsoft Azure HPC offerings, this Microsoft Azure virtual machines offer a wide range of HPC optimized virtual machines with a high CPU, memory, and GPU capabilities. It supports the parallel workloads and the large scale simulations, provides flexibility to run the diverse HPC applications. And next one is this Microsoft Cycle Cloud. It is a this is a powerful tool for creating, managing, and HPC scaling the HPC clusters. It automates the deployment and scheduling of compute resources. So it simplifies the cluster management and the job execution. Next, InfiniBand networking. And this is a high speed, low latency networking technology which enables the fast communication between the nodes in a cluster. So that is essential for performance critical parallel applications. So Azure combines several compute nodes, efficient cluster management, and a high-speed networking, that is to make it a strong platform for running high-performance computing workloads. And if you look at Azure features, like it supports the hybrid cloud integration, enterprise grade security, and strong AI integrations. Like Microsoft Azure hybrid cloud integration, which is mainly used for seamlessly connects on-premises infrastructure with the cloud resources. So that enables organizations to extend the existing HPC clusters to the cloud. So it provides the flexibility and the scalability without replacing the current system. Next, enterprise grade security, which offers the advanced security features like identity management, encryption, and compliance certification. So that ensures the protection of sensitive data and workloads. This is best suitable for industries like finance, healthcare, and research. Next, a strong AI integration, that is a deep integration with AI machine learning services. It supports tools like Microsoft Azure machine learning and cognitive services, that is to enables the building and deploying intelligent applications at scale. So Azure provides a powerful combination of hybrid flexibility, robust security, and AI capabilities, that is to make it an excellent platform for modern HPC and data-driven applications. Next, Google Cloud Service offerings mainly, that is HPC using the compute engine, customizable machine types, and a HPC toolkit for cluster deployment. So this Google Cloud Platform compute engine mainly provides high performance virtual machines for compute intensive tasks. It also supports the CPU and GPU based workloads. This is mainly ideal for simulations, analytics, and large scale computations. Next, customizable machine types. Like it allows users to tailor the CPU, memory, and storage based on the workload needs. It avoids over provisioning and reduce the cost. So that ensures the efficient resource utilization. HPC toolkit mainly to it's a deployment tool, that is to quickly create and manage the HPC clusters. It also automates the infrastructure setup and configuration so that it simplifies the cluster deployment and management. So Google Cloud Service Provider, it provides flexible and scalable HPC solutions with the customer configurations and easy deployment tools that makes it suitable for data intensive and high performance workloads. And if you look at the GCP HPC features mainly, that is high performance networking, offers a low latency, high throughput network between the compute instances. It supports fast data transfer across the nodes. This is essential for tightly coupled HPC workloads. And next, live migration, which allows the virtual machines to be moved between hosts without downtime. That also ensures the continuous execution of applications. So it improves the reliability and availability. Next, big data and analytics integration part. This the seamless integration with the tools like BigQuery, Dataflow, and the AML services. It enables efficient processing of large scale data sets. This is ideal for data-driven HPC and analytics workloads. So GCP, Google Cloud Service Provider, combines the high-speed networking reliability through the live migration and the powerful analytics integration. So that makes it a strong choice for modern HPC and big data applications. Virtual clusters. These virtual clusters, a virtual cluster includes a head node and a compute node, storage system, and a scheduler. So a head node A head node in this virtual cluster acts as the central controller of the cluster, so that manages user access, job submission, and resource allocation. It coordinates overall cluster operations. Next one is the compute nodes. These perform the actual computations and processing tasks, execute jobs assigned by the schedulers. This is a core unit where the parallel processing happens. Next, storage systems, and these provides the data storage and access for all the nodes. So it can include the shared file system or the distributed storage. This is mainly to ensure all the nodes can read or write the required data efficiently. Then the job scheduler, it manages the job queues and resource distribution. It assigns the task to compute nodes based on availability and priority, which is mainly used to optimize the performance and ensure the fair resource usage. So these components work together to form a scalable and efficient virtual cluster, that is to enable high performance computing in cloud and distributed environments. And what are the benefits of virtual clusters? Virtual clusters offer flexibility, easy deployment, and cost efficiency. The virtual clusters are flexible because the resources can be customized based on workload and requirements. It supports the different configurations like a CPU, GPU, memory, adapts easily to the various applications. It is easy deployment because the clusters can be set up quickly using cloud tools and templates. No need for a complex hardware installation. So it saves a lot of time and effort. So another feature is the scalability. The resources can be scaled up or down on demand. So it handles both the small and large workloads efficiently. So that is to ensure the optimal performance. And the cost efficiency, that is as it is based on the pay as you go model, that reduces the unnecessary expenses. So no need for expensive or on premises infrastructure. That means you can optimize budget usage. So virtual clusters provide a powerful, flexible, and cost effective solution for running high performance computing workloads in modern cloud environments. And if you look at the cost models of HPC, cloud HPC offerings, so in cloud high performance computing, organizations can choose from the various pricing models to balance the performance and cost based on their workload requirements. Instead of investing in expensive hardware, cloud providers offer flexible payment options like on-demand pricing, reserved instances, spot or preemptible instances, pay as you go, like this. So what are all this? What are the all these different pricing models? And if you look at the on-demand pricing, this is pay only for the resources used for hour or a second. So no long-term commitment. This is best for the short-term or unpredictable workloads. Next, reserved instances. This is commit to using the resources for a longer duration like 1 to 3 years and offered at lower cost compared to on-demand. This is ideal for the stable, continuous workloads. A spot or preemptible instances like used and it uses the unused cloud capacity at very low cost. So instances may be interrupted anytime. So this is suitable for a flexible, fault tolerant jobs. Another very important pricing model is pay as you go storage and networking. So pay based on the data storage and transfer usage. It helps to control overall cost. So cloud HPC pricing models provides a flexibility, cost optimization, allowing users to choose the best option based on workload type, duration, and reliability needs. So you pay only for the resources you use, that is making it ideal for the short-term workloads. That is the pay as you go model is a flexible pricing approach in a cloud computing where users are charged only for the actual resources consumed, such as compute time, storage, and data transfer. And if the main key features of this is no upfront cost or the long-term commitment, and the billing would be done based on the usage, that is for second or hour. This is very easy to start and stop the resources at any time. And why it is ideal for the short-term workloads, like mainly it is so suitable for the temporary projects, testing, and experiments. Avoids paying for the idle resources, so it allows the quick scaling without a financial risks. For example, if you run an HPC simulation for 5 hours, you only pay for those 5 hours of compute usage, not for the entire day or month. So the pay as you go model offers a maximum flexibility and cost control, so that make it perfect for the short-term dynamic or unpredictable workloads in a cloud HPC environments. There is the reserved instances mainly, and these are the pricing model where you commit to using the cloud resources for a fixed period that is typically for 1 to 3 years in exchange for a significantly lower cost compared to the on-demand pricing. That is, it is the key features of this pricing model is a long-term commitment and discounted pricing compared to the pay as you go, because you are going for a long 3 years, and predictable billing and resource availability. So if you look at the benefits, it reduces the overall infrastructure cost for continuous workloads, ensure the guaranteed access to the required resources. This is mainly ideal for steady and predictable applications. For example, if your organization runs a 24 by 7 HPC applications, so reserving instances can save a significant amount compared to paying hourly rates. So it has some limitations like less flexibility compared to the on-demand. It is not suitable for the short-term or uncertain workloads. So reserved instances are a cost-effective solution for the long-term stable workloads that helps organizations optimize the cloud spending while ensuring the consistent performance. And whereas the spot instances, also called as a preemptible instances in some clouds, allow users to utilize unused cloud capacity at a significant reduced cost compared to on-demand or reserved instances. So it is very low cost, that is often 70 to 90% cheaper, and uses the spare or unused resources from the cloud provider. So it can be terminated anytime when demand increases. So the main advantages with this spot instances: high cost efficient for large scale workloads, ideal for batch processing, simulations, and testing. And this enables running more jobs within the same budget. And it also has some limitations. Instances can be interrupted without warning, no suitable for the critical or time sensitive tasks. And so if so, then what are the best use cases, like fault tolerance applications, jobs that can be passed and resumed, distributed workloads with checkpointing. So spot instances provide maximum cost savings, but they require a flexible and resilient workloads that can handle the interruptions effectively. So if you could compare all this, so AWS is highly flexible, Azure is strong in enterprise solutions, and GCP excels in analytics and optimizations. So that's it. Let us quickly summarize what we had discussed in this. The cloud HPC is transforming how we perform the large scale computations. Choosing the right provider and cost model is key, that is the major key to maximizing the performance and minimizing the cost. That's it. If you found this video helpful, like, share, and subscribe. Let me know in the comments if you want hands-on labs on AWS, Azure, or GCP. Thank you for watching.